Stanford University.
Okay, well, welcome to lecture number 8 of Stanford CS 193P, fall of 2013 and 14. And today, we're going to talk about a couple of Objective-C things first, language features, basically, and then we're going to talk about animation. So animation is our topic of the day. I'll be starting a demo at the end, which we'll finish on Wednesday. And I'm going to demo pretty much everything I talk about, including the Objective-C things, and even including some of the things we talked about last week. So it's going to be a very big, comprehensive demo. That's why it runs over into two things. So the first Objective-C thing we're going to talk about is protocols. I hinted at this earlier in the quarter. This is a way that we're going to make ID a little more useful by making it a little safer. Okay? And we already have introspection to make ID safer. Well, we have something that's an ID. We know it's a pointer to some object. We don't know what kind of object. We know how to use introspection to ask at runtime, what kind of object are you? What kind of methods do you respond to? That's nice, but it'd be better if in our code we could document in a way that both the reader of our code can understand and also that the compiler can understand what it is we intend, okay, with that ID. What methods we plan to call on that ID. And so that's what protocols do. It's basically syntax. It's just syntax in the compiler. Nothing more than that. It's kind of the same thing, NS string star versus ID. That's really just syntax in the compiler. That makes no difference at runtime. And the fundamental part of the syntax is right here, ID, angle bracket, protocol, obj. So that's declaring a variable of type obj, which is an ID, but it's got this additional little thing, my protocol, which tells the compiler and readers of your code a little bit more. So let's talk about protocols and how this all works. The first thing we're going to talk about is how to declare a protocol. And declaring a protocol looks almost exactly the same as an @sign interface statement. Okay? @sign interface is where you put all your methods and properties that are public, or you can have an @sign interface at the top of your implementation and have private methods and protocol and properties. And the same thing for a protocol. It's just that you say @sign protocol instead of @sign interface. Now, a protocol is just a declaration of the methods. There's no implementation. So there's no @sign implementation for an @sign protocol. We're just talking about the methods. And the methods in a protocol by default are all required. Okay? So that means if someone wants to say that they implement this protocol, they have to implement all these methods. And so those are all the methods in my little sample protocol here. You can make some of them optional by putting @sign optional in there. And now all the rest of those are optional. So now in this example, some method is required, but all the rest are optional. And you can put @sign required again, down a little lower. Now all of these are required except for method with argument is optional. Okay? So we're basically defining a little pile of methods, some of which are required and some of which are optional. Okay? That's what a protocol declaration is all about. Now you see how I've added x, y, z, z, y in angle brackets after protocol foo there. So what that says is if you want to implement, if you want to say you implement protocol foo, you also have to implement all the required methods of protocol x, y, z, z, y, whatever that is. Okay? So it's basically a way of kind of like super protocol. It's not really, it's not inheritance or anything, but it just kind of adds to the methods that is required by a protocol. And in fact, you can have multiple ones. So here's protocol is now requiring you implement the XYZZY protocol and a protocol called NSObject. Okay, now let's talk about this NSObject protocol because it's a very common protocol. You're used to the NSObject class, right? And NSObject protocol is basically a protocol that includes almost all the methods in the NSObject class. Okay, and why do we do this? Why do we have a protocol named NSObject and a class named NSObject? And they have pretty much the same methods in it. Is equal, is kind of class, description, perform selector, all those NSObject things. The answer is because we sometimes want to declare a protocol where some methods are required, but we also want to require the thing that implements the protocol to essentially be an NSObject. Okay, we want it to be an NSObject. We want to be able to maybe use introspection, things like that. Well, the only way to do that is to have the protocol have like a super protocol, you know, it's an additional protocol. And so we just took all the methods in NSObject, we put them all in a big protocol and have NSObject implement that protocol. Okay? So NSObject protocol and class, all the same methods, pretty much. Okay? It's just that NSObject, the class, is an actual implementation of those methods. So where do these protocol declarations, oh yeah, sorry, question.
In Java, all classes automatically inherit from object. Is that not the case with NSObject here?
Yeah, so the question is, in Java, all classes pretty much inherit from object, and that's not true in Objective-C. You could have a class where it just says @interface, name of class, no : superclass, in which case it inherits no methods from anywhere. Okay, it will only have its own method. We never do that, however. In iOS, we always inherit from NSObject because we want the introspection and all these things. So, but it's by convention rather than by some sort of enforcement for the compiler. All right, so these @protocol declarations of these methods, where do they go? They go in header files. They can go in their own header file. Okay, so I could have a foo.h for my protocol foo. Or they can go in the header file of some related class, like some class that wants somebody to implement that protocol. You could put it in there. So, for example, iOS has scroll view class, right, for scrolling. We're going to talk about that next week. It has a protocol called the UI scroll view delegate, which is a bunch of will scroll, did scroll things, methods. And it's only good for UI scroll view, so that delegate is, that protocol is defined in UI scroll view.h, not in its own header file. Okay, so you can kind of do whichever one you want, and you'll see them both ways. All right, so now we have the protocol declared. We defined this little bundle of methods, including the setters and getters of properties, perhaps. Now, some class has to promise to implement that protocol. And how do you promise to implement a protocol if you're a class? You just put angle brackets, the name of the protocol, on your @interface line. Okay? So here it's my public @interface line, and my class inherits from NSObject, angle brackets foo. That means my class is promising to the compiler and to readers of this code, I'm going to implement all the required methods in foo. Okay? So I'm just making that promise. And you can make the promise publicly like that, or you can make the promise privately by putting it in your @interface, my class, parentheses thing that goes in your implementation. Okay, you can just put it there if you want. That's if you only need to be able to implement that. You're only required to implement that protocol for something that's in your implementation only. Okay, not any public thing. Okay, so now I've got a protocol. I've got an object, at least one, that signs up to implement it. Now what? Well, now I can declare variables that are IDs with the additional requirement to implement the required methods of a protocol. So ID angle bracket foo obj, hopefully you understand what that means now. That means obj is a variable. It's an ID. I have no idea what class it is. Okay, it's ID. It's completely blind. However, I know it implements all the private or the required messages in foo. Okay, and it might implement some of the optional ones too, but I know at least the required ones. So if I say ID angle bracket foo obj my class alloc init, that looks good because on the previous slide I just said that my class promised to implement foo. So the compiler's going to love that. But if I said ID foo obj ns equals ns array, that compiler's not going to like that because arrays clearly don't implement the protocol foo. They don't implement those methods. Okay? So the compiler will warn you in that case. Okay, so the compiler here will warn you if you do this. It'll also warn you if you sign up to do a protocol, you promise to do something, and you don't implement the methods that are required, it will warn you about that too. Okay, so it'll warn you on both coming and going. In addition to declaring variables, like local variables under the examples there, you can also pass these around, these IDs that are modified by a protocol, as arguments to methods and as properties. Okay? So it's really just another type. It's not quite an NS string star where you know exactly the class and all the methods exactly that it does, but it's not quite an ID where you know nothing about it. It's in between, right? It's an ID, but you kind of know some of the methods in foo. Okay? Just like static typing, this is all just syntactic sugar in the compiler. It makes absolutely no difference at runtime. No code is generated any differently by the compiler because of these things. The compiler is just able to warn you now. That is the only difference. Okay, some people have a little difficulty accepting this, but it's true. No code generation is any different by the compiler because of these protocols. Same thing with NS string star versus ID. It's all exactly the same stuff gets generated by the compiler. It's just the compiler can warn you because they know what you intend. Okay? The number one use of protocols in iOS is delegation and data sources. This is back to, remember lecture 1, I had the MVC and I told you that the views could talk to their controller with blind structured communication. And we talked about will do this, did do that, or the data source, which is data at, count, that kind of stuff. All those, remember that communication? This is how we do that. So it's blind because they're IDs. The views are talking through IDs, but it's structured because there's a protocol. that the view uses to talk to that object blindly so that it knows what's in there. So let's talk about, for example, the data source protocols of views. If it was a table view, let's say, a table view is a generic view for showing a table of information. Its protocol for accessing its data source is how many rows are there? And now give me the data at row 7. Give it data at row 500. Okay? That's its protocol, those methods, count and data at. It has other ones, but that's the base. Those are the basic ones, okay? And we really need those data source protocols because views can't own their data. That table view can't grab all its data and display it. It has to keep asking someone else, but it doesn't want to be tied to any source of the data, so it wants to be an ID. It wants to be blind, okay? And we'll see all this next week when we talk about table views. There are other uses of protocols besides that blind structured communication, and we're going to see one today, which is animation. And I'll let that speak for itself. But basically, we're going to have IDs out there that are animatable, and we're going to know they're animatable because they're going to implement a certain protocol. And that's how we're going to know that they're animatable things. And UI View is going to implement that protocol, and that's how we're going to animate our views. All right, the second Objective-C thing I want to talk about today is blocks. Okay, it's a totally different thing than protocols. Blocks, very important, used throughout iOS. In fact, I sometimes have difficulty getting all the way to week 5 here or 4 without putting blocks because it's so much in the API of iOS. What is a block? A block is a block of code. Okay? Why do we define this term block? Just to mean block of code. We already know that. It's because it's a block of code that can be embedded inside other code, passed as an argument, stored in an array. Okay? So it's a block of code that we manipulate and move around our API. So what does it look like? Here's an example of a method that takes a block as an argument. Okay? This is the calling of this method. This is an NS dictionary method. It's a real method. It's called enumerate keys and objects using block. Okay? The argument is a block that has no return value and takes 3 arguments. 2 of the arguments are IDs, which are the keys and values in the dictionary. And the third one is actually a bool star, a pointer to a bool. So it's a bool. It's an outgoing bool. Okay? And basically, when you call this method, dictionary will execute that block of code repeatedly for every key and value until you set the stop, star stop, to yes, or until it runs out of keys and values. Okay? And it's actually going to implement that code that's right there embedded inside that message call. You can see the open square bracket for enumerate keys and objects before a dictionary. The closed square bracket is down after the curly brace. Okay? So the code, the actual curly brace, we put right in there in the middle of our message call. Other languages, in computer science in general, we call this a closure. Okay, how many people know the name closure? Ever heard that before? Okay, so you guys generally know what this is. It's a closure. Blocks in Objective-C always start with the caret. That's the magic block character. And then there might be a return type, possibly specified, and maybe some arguments, possibly, and then a curly brace and some code and an end curly brace. Now, of course, to make this really interesting,